the next one, another rule under differentiation, which is called the generalized power function, right? Generalized power function. We can also use the power rule to do that because it is raised to a power, right? That's the idea. So given that, or given the function y is equal to x to the power n plus 1 all raised to the power p, the derivative with respect to x can be obtained using the general formula, right? So bring the power in front of the function, x into bracket, bring the power in front of the function, x to the power n plus 1, reduce the power of p by 1, multiply by the differential of what is in the bracket, x to the power n plus 1, right? Bring the power in front of the function, reduce the power of p by 1, multiply it by the differential of what is in the bracket here, xn plus x to the power n plus 1. So this formula here, or this function here, can be also rewritten, or it can be written in this way, right? So where you have a function u to the power a, it is raised to a power. So we can use a generalized power function, which is saying that bring the power of a in front of the function. So that gives you au. Reduce the power of a by 1, that is a minus 1. Then you multiply it by the differential of the function, which is your u here. So du over dx, right? Note that this generalized approach is in fact the chain rule, where dy over du is equal to au to the power a minus 1 times, right, a minus 1 times your du over dx, right? Please take note of that, times your du over dx. All right, moving on to the next slide, where we'll be talking about the basic rules of logarithm. So a common logarithm is a logarithm with a base of what? 10. So a common logarithm is a logarithm that has a base of 10, which could be written as log x or log x base 10. It is defined as the power to which 10 must be raised to equal to x. So these are some of the rules governing the common logarithms, right? We have the first one, which is called the product rule. So product rule, you can see that it is log of a multiplying b, right? So log into bracket a times b. So where you are multiplying, right? So those of the terms, or the terms that are multiplying in a bracket here, becomes what? Addition outside, right? So we have log a times b. It is equal to log a plus log b. The quotient rule is when you have log a divided by b, right? So the terms that are dividing here, a over b, becomes minus, or yes, it becomes minus outside. So we have log a over b, it is equal to log a minus log b, right? So we have the next one, which is the power rule, where you have log a to the power n. Log a to the power n here, the exponent inside the bracket, which is n here, right, becomes what? Multiplication outside. So you can see that log a to the power n here, then n here is rather multiplying log a. So the exponent becomes multiplied by what we have here. Okay, so the exponent becomes multiplied. The exponent here is multiplied by what we have, log a here. Okay. Looking at the next one, where we have what is called the identity rule. Identity rule is just saying that if you multiply log 1, right, if you have log of 1 is equal to 0, right? And then the 0 rule is also saying that if you have log 10 to the base 10, it is equal to 1. Chain of base, right? Chain of base is a rule that lets you convert logs or logarithm from one base to another using a common logarithm. So here you can see that we have log BA. It is equal to log A over log B. right? So it's just helping you to convert logarithms from one base to another. Okay. On the left, on the right hand side here, we have the natural logarithm, or what is called ln. The rules of natural logarithms ln are derived from the properties of the exponential function with base e, and they are essentially the same rules as for other logarithms, but with the base e. Okay, so natural logarithm is a logarithm with the base e, right? Where the base e over here is approximately 2.71828, right? That is the base e here. So it is written ln of x instead of log e or log x base e. Okay, it is written as log or ln of x instead of log x base e. That's what they are trying to say. Okay, or that is what this natural log simply means. So we have the product rule as well, where we have natural log of n, natural log of ab, sorry. So ln of ab is what? Ln of a plus ln of b. Quotient, the same thing. Ln a over b will be ln a minus ln b. Same applies to the power rule. You have the natural log of 1 is 0. The natural log of the base e, or natural log of e is 1. The natural log of 1 over x is minus natural log of x. Right. So let's move on to the other aspects of the topic, or the other areas of the topic. We'll be looking at examples under what we call special functions. So what are special functions? Special functions are also rules under, or they are also functions that we deal with under differentiation. So you could have something like y equals ln of x. The general form of the derivative of this function is just saying that dy over dx, dy over dx, which is the differential, is equal to 1 over the function times the differential du over dx is the differential of that same function you have here. So what is the function? The function is such that if this ln is being taken away from the term, what is left here is x. X is the function we are talking about, right? So dy over dx of something like this ln of x is such that it is 1 over x, which is the function, times the differential of x, which is 1. So this is an example to explain what you are saying. Find y prime if y is equal to ln of x. So we would say that which of these terms here, or which one is our u, or which one is our function? It is the x here when the ln is taken away, so x. So let u be equal to x. Then we'll say that du over dx is equal to 1. The differential of x is 1. So back into the formula, it says dy over dx is equal to 1 over the function times the differential of that same function. The function here is x. So 1 over x times the differential of x is 1. And that will give us 1 over x, which is simply telling us that the differential of the natural log of x is 1 over x. Let's look at a more complex example where we would have to deal with the same special functions, but a bit tougher than what we just did. Right? Find y prime if y is equal to ln of x squared plus 5 all squared. First of all, you have to identify what our function is. Our function is x squared plus 5 all squared. Let u be equal to that function. And find the differential of that function. So the u over the x here will give us, bring the power in front of the function. So 2 here in front of the function, multiply it by x squared plus 5, reduce the power by 1, that is 1 over here. Then you multiply it by 2x. Okay, and that will give you the du over dx. So the next thing is I just substitute it back into the formula with Ledge length, or we just talked about. So dy over dx is equal to 1 over the function, which is x squared plus 5 all squared, multiplied by 2 into brackets x squared plus 5 times the differential of what is in the bracket, which is what? 2x. The next thing is that we multiply this 2 here by 2x. That will give us 4x. 4x by 1 gives us the same 4x. So you would have 4x into bracket x squared plus 5 all over x squared plus 5 all squared. But the x squared plus 5 that you have here will cancel one of these x squared plus 5 that you have here, which is raised to the power 2. And you'll be left with this final answer, right? So the differential of this function here is equal to 4x over x squared plus 5. Right. Another approach for this problem is to know that according to laws of logarithm, y is equal to ln into bracket x squared plus 5 all squared. Then you have 2 ln into bracket x squared plus 5. Then if x squared plus 5, if u is equal to x squared plus 5, then dy over dx is 4x over x squared plus 5. This is the same procedure. It's just explaining how you can go about this in a different idea or a different approach, right? So we can use these basic steps to solve any natural log functions, right? Let's take a look at another example. Find y prime if y is equal to natural log of x squared plus 2 all raised to the power minus 1. We have to identify our function. The function here is what? It's x squared plus 5 all squared minus 1. That is, let u be equal to that function. Then find the differential of this function, du over dx, which is what? Minus 1 right. For this question here, so we would say that u is equal to the function in the bracket, which is the function here, which is x squared plus 2 all raised to the power minus 1. Then the differential of this u with respect to x, that is du over dx, is equal to minus 1 multiplying x squared plus 2 all raised to the power 2. Bring the power in front of the function, reduce the power by 1, gives you minus 1, that is minus 2. Multiply it by the differential of what is in the bracket here, x squared plus 2, that will give you 2x. So back substitute it into the formula, or just bring it back, substitution. So we have dy over du being equal to 1 over the function here multiplied by du over dx, which is this function. Then negative 1 times 2x gives you negative 2x. And if you reduce this, x squared plus 2 all to the power minus 2 over x squared plus 2 raised to the power minus 1. We're going to be left with x squared plus 2, right, indices. Or simply, you can go by the logarithm approach and you get the same answer for this function, right? So